Hello there, this is Angie with Angie's Beyond the Lecture. We are now on the second section of our chemistry final exam review. And in this section, it's basically covering properties of matter and changes in matter. And I'm going to scroll down just momentarily. Yes, we'll also talk about intensive and extensive properties, and then states of matter will have its own video. So back to the top here again, we'll just discuss really quick what physical properties and chemical properties mean in a general sense and the types of questions you might see. So physical properties are basically observational, and in essence, they don't, when you measure these properties, they don't change what the substances are by identity. So things like this include color, density, melting point, boiling point, odor, we have mass, and also volume. Okay, melting point is actually a very key way of identifying physical properties or actual substances and what they're, how you identify them by name, right? Density as well. So again, anything that identifies a particular substance and we can measure it, but it's not going to change what the actual identification of that substance is. When we go to chemical properties, it's a little bit different because this describes how that particular substance reacts with its environment, with other substances. So key examples of this would be flammability, reactivity with acids or oxygen being the air around us, and its ability to decompose or break up into its constituent parts. So classic examples would be on a question, this particular property, is it physical or is it chemical? Please identify it for me. You could say a certain substance boils at a certain temperature. Is that physical or chemical? And you would say physical. On the flip side, if you're told that a particular substance has flammability in certain conditions, you would identify that as a chemical property. Okay. Now, changes. Below here, we have physical and chemical changes. Now, physical changes are just simply demonstrating a change to that substance, but it doesn't actually change the identity. And classic examples are melting, freezing, boiling. Those are states of matter changes, states of matter, what we'll discuss here shortly. So if you have an ice cube and you melt it into water or liquid water, it's still water. Ice water and liquid water are the same thing. They're still H2O. Same with dissolving substances, mainly in water. Breaking or crushing items. So if I take maybe a piece of wood and I chop it up into smaller logs, that would be a physical change. Now, if I throw that log on the fire and burn it, that would be a chemical change. And that's our next entry here. We talk about chemical changes, and that's basically creating new substances with entirely new properties. And this would be the heart of chemical reactions. We take one substance and make it into a new substance, whether it's decomposing it or breaking it down or combining substances to make new substances. You get the idea. We're going to break chemical bonds and reform them and in turn form new substances. Now, clues for chemical change would include, clues for chemical change would include a color change, the formation of gas or gas bubbles. There's a temperature change. That means the chemical reaction took heat in and made its surroundings colder, or released heat or heat out and made its surroundings warmer, indicating some kind of chemical reaction took place. We also have the formation of a solid, and in this case, we call it precipitate. And this is where we can typically we combine two aqueous solutions with water and different solutes in them. And what they do is they break up in the water and the parts, the different ions combine to make a new solid. And you can tell a chemical reaction took place. New odors are also a key hallmark of a chemical change. So we've gone over physical properties, chemical properties, physical changes and chemical changes. And really, when it comes to chemistry quizzes and exams, you're just asked to identify, given a certain scenario, which change might be physical or chemical, or perhaps which property might be physical or chemical. Or an alternative would be you could be given a list of maybe 4 or 5 options, and you have to identify what change is physical, what change is chemical, and also which changes or which property is physical or which property is chemical. It can be a mix, but those are your typical types of questions you'll see. And last but not least, we can actually break substances into additional properties. Okay, yeah, and then we go into states of matter. So let's back up just a tiny bit. Now we have intensive and extensive. This is often a forgotten property that I see with students. And again, it's just good to go back and review this because you might see a question like this on your quizzes and in particular on your final exam. Now, when it comes to intensive or extensive, the key difference is, does it matter how much substance you have? With intensive, it does not matter. These properties include density, color, melting point or boiling point, hardness, and general odor that these substances might have. So to go back on like melting point or boiling point, whether you have perhaps a small ice cube or a huge iceberg, that particular substance is going to melt at 32 degrees Fahrenheit or 0 degrees Celsius. It's also going to boil at 100 degrees Celsius or 212 degrees Fahrenheit, assuming there aren't a lot of impurities in it, okay? So again, and that's a key. Melting point and boiling point here are pretty, I'm going to circle these real quick. Yeah, these two guys right here are sort of trick questions. I think students tend to forget that's not an extensive property. It's intensive. It does not matter how much you have. A certain substance will melt or boil at a particular temperature, no matter how much you have. Now, extensive properties do depend on how much you have, and classic examples are going to be mass, volume, length, and last but not least, total heat content. Okay, so remember, intensive is independent of amount. I went ahead and made a bold entry there for independent. Extensive depends on the extent of matter that you have. So hopefully this helps on these key topics when it comes to intensive, extensive, and then also your physical and chemical changes and properties. Thanks again for watching this video, and I'll see you in the next video.